This is GMAX 41, your channel of excellence. So I welcome you to the part 2 of your experimental work on Physics 108, Physics Practical. So in this live class, we are going to provide solutions to the follow-up questions in experiment E6 to determine potential difference across a resistor. So once you join this class, know what to do as always. Just right away, share the link to this video to your friends, to your classmates. Invite them to join. So for all the students that are perhaps free now, they can join this class as I make the analysis of the follow-up questions in your experiment E6. I've decided to go live with screencast mode so that I can be able to display the solutions and of course the diagrams, all right, to the staffs that you have there. All right, so we are going to move on right away. Let me share the link to this live class to other students so they can join. Please, once you join, help me and share the link to your friends, to your departmental WhatsApp group. Okay? All right, so we are going straight on to the questions that we have there. There are two main calculation questions under this experiment E6. We are done with part 1 where I carried out a live demonstration of the experiment. Okay, so this is part 2. I've also guided you on how to plot the graph because in this experiment, you are meant to read and record the current, evaluate the inverse of the current, and then plot the resistance values given against the current. Now against the inverse of the current. So you are required to evaluate the slope, you are required to evaluate the intercept. So that I had explained in part 1. I've also given you the idea, knowledge on the precautions you need to take to ensure accurate results, accurate reading in part 1. So let us see our very first question in this part 2. Let's see what we've got, okay? So the question in part 2 here, let's see what we have. Good. So this is question number 3, actually, although I tagged it as question 1, but this is actually question number 3 of the follow-up questions on experiment E6. So let us read it, and then you follow up with the calculation. That question 1 is actually question number 3 in your experimental work. And then question 2 here is actually question number 4. It has I and II, according to your manual for the students in Unizik. Why do this experiment is targeted towards students in Unizik? Because they are the ones working on this experiment this week. Any other scholar from any school, any part of the world that is undertaking electricity course also need this particular class. All right, so it is not specific to any particular school or whatever. Every science and engineering student, medical student need this because they also offer electricity course. So the very first question we have there, which corresponds to question number 3, a parallel combination of 3 ohms and 6 ohms resistors is connected in series with a 5 ohms and a battery of internal resistance 1 ohm. Calculate the effective resistance in the circuit. So this question, we have to calculate the effective resistance in the circuit. That's what we are asked to do. Trying to see how I can share this to other friends. I don't seem to be able to do that. Okay, anyway, you can help me and share to others. And I've always said, if you are not subscribed to this channel, please subscribe right away. And then turn on the notification bell, select all, so that anytime I kick off any class as this, you will be personally notified. Okay, you will be personally notified. So let's move on. So this very first part of the question, what we are required to get is the total resistance in this circuit described here. The total resistance in this circuit described there. Akachuku Divine, you are welcome to join the class. All right, welcome. Now, if you look at this problem, we are told that we have a parallel combination of 3 ohms and 6 ohms resistors. So we have 2 resistors. Their value, the value of the resistances are given 3 and 6 ohms. They are connected in parallel. Now, this parallel combination is now connected in series with another resistor whose resistance value is 5 ohms. Now, the internal resistance of the battery was given to be 1 ohm. Calculate the total, the effective resistance in the circuit. So with this idea, parallel connection of 2 resistors, 3 and 6. Now this parallel connection is connected to a 6 ohm to a 5 ohms resistor. Let's see what the diagram looks like. Okay, let's see what the diagram looks like. Let's see what the diagram looks like. So this is the diagram. This is the diagram. You can see that. All right. 3 ohms resistor connected in parallel with 6 ohms resistor. Now that arrangement is connected in series with a 5 ohms resistor. You see the diagram showing there? Let me make it a bit bold. Experiment E6 calculation. Now you can see the cell where I labeled small r equal to 1 ohm. Small r equal to 1 ohm. That is the internal resistance of the cell. So this is the circuit diagram. If you are providing the answer to this question, in fact, you can gain extra mark. Yes, if you're able to bring out this diagram, even though you were not asked to draw the diagram. But one thing is, different lab technologists or your examiners marking this, any one of them might be impressed by the fact that you brought out the diagram and then decides to give you extra mark. So this is the diagram to that question number 3. We are now to calculate the effective resistance. So looking at this diagram, to get the effective resistance is 1 plus 1. I'd already done wonderful works on this through Physics 102. On this channel, if you go through the playlist, you have, Physics 102 playlist on this channel, and you can take lessons on electricity and learn how to resolve resistors in series and in parallel. So for this, what we have to do is to resolve the 3 ohms resistor and the 6 ohms resistor. We resolve them in parallel, which of course, if you want to use the formula 1 over R equal to 1 over R1 plus 1 over R2 for the 3 and 6 ohms resistance. Are you following right? You would get the combined resistance for these 2 parallel guys, which will now be in series to that 5 ohms. For example, if you do that, I think you are going to be getting there about, let's say, 2 ohms resistance or so. But anyway, there's a better approach to calculating the parallel resistance that you get an equivalent or a single resistance value for them, which will now be in series to the 5 ohms. Since you have 2 resistors in parallel, you can just multiply their resistance values and divide by the sum of the resistance. That is 3 times 6, which is 18, divided by 3 plus 6, which is 9, giving you 18 over 9, which is 2. Add the 2 to 5 ohms resistance. That will give you the external resistance value. Now, to get the effective, the overall resistance, add that 7 ohms external resistance to the 1 ohms internal resistance to get 8 ohms. So the effective resistance is 8 ohms. And here you have the calculation shown. Let me show you the calculation. You have seen the diagram. So here we have the calculation. So look at it. This is the solution to that question number 3. I've given the interpretation on what you are expected to do. But here now you have the clear solution. To get the effective resistance, capital letter R, is going to be equal to R1 dot R2. That point there represents times. R1 times R2 all over R1 plus R2, which is the parallel combination of 3 and 6 ohms resistance. Then add it to R3, which is that 5 ohms resistance. Whatever you get, you add it to the internal resistance, that small letter R. So I decided to declare the resistance values that I labeled R1, R2, R3. R1 is the 3 ohms resistance given in the question. And then R2 is the 6 ohms resistance given in the question. R3 is the 5 ohms resistance. And then the small letter R is the internal resistance of the cell. So the first thing is to solve the parallel combination of the 3 and 6 ohms resistance. And you can see the calculation there, R1 dot R2. How do you obtain it? It's going to be 3 times 6 divided by 3 plus 6. You have the formula there already. R1 is 3 times R2 is 6 all over R1 is 3 plus R2 is 6. Now that gave us 2 ohms resistance, just like I explained earlier. Then the 2 ohms resistance, to get the total resistance, the effective resistance, add it to R3. R3 is 5. That is why on the right hand side of the calculation, you now have R equal to 2 plus 5. That 5 is the R3 resistor, 5 ohms. Then plus small letter r, which is 1 ohm. If you add 2 plus 5 plus 1, you will get 8 ohms. So the effective resistance in that circuit in question number 4 in your manual, sorry, question number 3 rather in your manual, which I have tagged question 1 here. Are you getting me right? The effective resistance in that circuit is 8 ohms. So this is the calculation you are meant to take down, exactly as you have it there. Now observe the way I calculated my parallel combination of R1 and R2 resistors, that is 3 ohms and 6 ohms resistor. It's not compulsory that you must go through this pattern, R1 times R2 over R1 plus R2. You might decide to do 1 over R1 plus 1 over R2, which is 1 over 3 plus 1 over 6. Work out the LCM, you still get that 3 times 6 over 3 plus 6, okay? Once you are done with that, add it to R3, because the result you are going to get from the parallel combination will be in series with the R3 and also in series with the internal resistance of 1 ohms. So however you want to do that, the choice is yours. Just that when 2 resistors are in parallel, I've always said, for me, I prefer using the approach, multiply the 2 resistance values divided by the addition of the 2 resistance values. It's faster than going to do 1 over something, okay? All right, but when, of course, the resistors, they are up to 3 and above, you can now work on your 1 over, 1 over, 1 over for parallel combination. We are done with this question number 3. Let's go back to the question, and then you will see it again, what we have done. Where is it? The question. Okay, so look at it. Labeled as question number 1. The parallel combination of 3 ohms and 6 ohms resistors is connected in series with a 5 ohm resistor, right? And then the battery of internal resistance 1 ohms. Calculate the effective resistance of the circuit. So we are done with that. Let us move on to the second question. Question number 2 there. An electric bell takes a current of 0.2 ampere. An electric bell takes a current of 0.2 ampere from a battery of 2 dry cells. From a battery of 2 dry cells connected in series. Connected in series. Each cell has an EMF of 1.5 volts and an internal resistance of 1 ohms and an internal resistance of 1 ohm. Take note, each cell has an EMF, electromotive force, of 1.5 volts and an internal resistance of 1 ohm. Calculate I. Calculate I, the resistance of the cell. The resistance of the cell. II. what amount of current will be delivered to the bell if the cells are arranged in parallel? If the cells are arranged in parallel. So how do you analyze this? Now you have an electric bell. This electric bell is taking a current of 0.2 ampere from a battery of 2 dry cells, just like the battery you saw in part 1 in the live practical on this experiment E6, whose follow-up calculations we are dealing with now in part 2. So those 2 cells, their EMF is 1.5 volts each. Okay? And we are told from the question that each of them has an internal resistance of 1 ohm and an internal resistance of 1 ohm. So what is the resistance of the cell? What is the resistance of what? The cell. Now, you know, cells, right, have internal resistance. And since both of them here are connected in series, they are connected in series. The first part of this question says you should calculate the resistance of the cell. It means you are going to calculate the 2 resistance in series. Are you following? Look at something like this. Don't know if you can see this. We have 2 batteries here. I made use of this battery in part 1 of this experiment E6. This is series connection. So if each of them has internal resistance of 1 ohms, as the question suggested, when resistors are connected in series, what do? You add them up. So in this case, we are going to get that 1 ohms plus 1 ohms, which will give us 2 ohms. By the way, let us see what the circuit looks like. Let us see what the circuit of this guy looks like. Look at it. This is the circuit to that question. Remember, we are dealing with question number 4 in your Physics 108 manual. But here I tagged it question 2. Okay? So you can see series cell. When the cells are connected in series, you can see the connection there. You can see the bell. All right? You can see the bell there that is taking a current of 0.2 ampere. Internal resistance, each of them is 1 ohm. So R1 is equal to R2 and is equal to 1 ohms. Or 1 ohm. Then the cell has EMF of 1.5 volts, each of them. So E1 is equal to E2, which is 1.5 volts. So if you have to calculate the resistance of the cell according to the question, all you have to do is to pick the internal resistance of the cell, because the cell, the resistance it has is internal resistance. Okay, add both of them. The small letter r, you're seeing the R1, R2. Add both of them, you're going to get 1 plus 1, because these cells are connected in series. The effective internal resistance will be the summation, the addition of the 2 internal resistances. So if you add them, 1 plus 1, you should get 2. Is that okay? 1 plus 1, you get 2. Of course, look at it, the solution. Since the cells are in series, the effective internal resistance is small letter r equal to small letter r1 plus small letter r2. Remember, I'm using small letter r to represent internal resistance. So simply r1 plus r2, which will now give you 1 plus 1, and that will be equal to what? 2. So 2 ohms is the internal resistance of the cell. That's the resistance of the cell. So I part of question 4 is given as what you have there, 2 ohms. All right, let us move on to what they ask us to get further. What amount of current will be delivered to the bell if the cells are arranged in parallel? If the cells are arranged in parallel, what amount of current will be delivered to the bell? Remember, when the cells are arranged in series, the bell was taking a current of 0.2 ampere. I repeat that again. From the question, when the cells were connected in series, we are told that the bell took a current of 0.2 ampere. So the II part of this question is now asking, what amount of current will be delivered to the bell if the cells are now arranged in parallel? So what will you do? You have to solve for parallel combination. You have to solve for parallel what? Combination of the resistors. Because when the two cells are now in parallel, if the cells are in parallel, are you following, right? When cells are in parallel, you have something like this. Let me show you. I hope you can see that from here. When cells are in parallel, let's say, Henry, you're welcome to the class. This is a battery. For cells to be in parallel, they will be arranged like this. They have a wire connected from here to this point. Another wire connected from here to this point. Something like this. And when they are connected in parallel, you know how to get the total resistance, in that case, the effective resistance. All right. So having said this, in the I part of the question, to get the effective resistance, internal resistance of that cell, you will solve parallel combination of the 1 ohm and 1 ohm value there. In fact, look at it. Let me show you the connection when they're in parallel. Although I tried to do something in the case of series connection, I went further to do some other works. Although you were not asked to do this further calculation according to the instruction. But take note, your lab technologies can change it for you anytime. They can ask you to calculate the resistance of the bell. Look at the solution showing here. Actually, in the I part of question 4, you were only asked to calculate the internal, as in calculate the resistance of the cell. Look at it. Calculate the resistance of the cell simply, which is 2 ohms, I said. But I went further under that condition of series connection. I still went further to do some things just to help students to gain further knowledge. Because in the laboratory, your examiner can ask you, okay, fine, you have this instruction in your manual. Now, I want you to do something else. And what is it? Go further to calculate the resistance of the bell. Look at the bell. Calculate the resistance of the bell in this series connection of the cell. Because the resistance of the bell was not given to us. That bell is providing external resistance in the circuit. Is providing external resistance in the circuit. So you can be asked to calculate that. It's possible. So let us assume you're asked to calculate that in your laboratory work this week. And even if it is not in your laboratory work, what about your examination? What if you asked to calculate that? What would you do? That is why I went further. Like I've always said, this is a full-blown online school dedicated to teaching you, not just you coming here and then you get just one thing. That is not a proper way of learning. Have the network of your brain expanded, because anything can happen. You can be tested on anything, anytime. At least you guys are aware sometimes adjustments have been made to your manual work. The instruction given in the manual, the questions given there. All right, so under series connection, still in I part of the question, although we have answered it, the resistance of the cell is 2 ohms. But under that series connection, we can get the effective electromotive force. That is the total electromotive force in series connection. The total electromotive force in series connection will be to add the 1.5 volts electromotive force of each cell, because the question said that each cell has an electromotive force of 1.5. So for the two of them in series like this, it's going to be 1.5 plus 1.5, which will give us 3 volts. But if you measure this thing using a voltmeter, like I explained in part 1 of this experiment, you won't get 3 volts. You won't, because the internal resistance of this battery, this cell, will reduce the electromotive force of the cell. In fact, when we did it in our live practical, that was in GMAS 41's physical tutorial in Unizik, what we got was about 2.8 or 2.9, and that is what is expected if you measure the EMF. So in that part 1, for anybody that is going to record EMF, because we're asked to record that. Yes, I did the analysis on this paper when we're carrying out the live practical in part 1. If you record 3 volts, honestly, an examiner that has the full idea of what this should be, if you are to carry out a live practical of it, will fail you there. You shouldn't get 3 volts. But in calculation, we are not considering any loss there, because we are not using the battery live to now account for the chemical reactions taking place inside the cell. So for calculation, we go in the case of ideal situation. That is why you add 1.5 to 1.5, you get 3 volts. So the EMF will be 3 volts. Now, under that case, you can calculate the external resistance in the circuit, which is the resistance of the bell. The resistance of the bell, I use capital letter R for it. Now look at what you do. You're going to use the formula that current is equal to electromotive force divided by the sum of internal resistance and external resistance, small letter r plus capital letter R. You can see it there. Now, under that series connection, remember that the question said that the bell took a current of 0.2 ampere. So in place of I, you fix 0.2 ampere equal to, in place of electromotive force, capital letter E, you fix 3 all over, in place of small letter r, which is the internal resistance of the cell. In series, we got it to be 2 ohms. So you fix 2 for the small letter r, then plus capital letter R, which is the external resistance, the resistance of the bell, because the bell has its own resistance. And when we did that, we calculated the resistance to be what? 13 ohms. And in fact, you need to know the resistance of this bell. You need to know it. I'm going to tell you the reason. Look at question number II now. The II part, we are asked what amount of current will be delivered to the bell if the cells are arranged in parallel. So in fact, this question, you even need to calculate for that external resistance of the bell. You need to. That is why you need to get, you know, the electromotive force values and, you know, when it is in series. Then use to calculate the external resistance of the bell, capital R. We got 13 ohms. So this bell in question here, this bell in question, I use Z notation, you know, that red Z notation with dotted circle around it. The resistance of that cell, capital letter R, is 13 ohms as calculated. And it won't change whether the connection of the cell is in series or the connection of the cell is in parallel. The resistance of that bell will remain the same. It's just like somebody giving you this in an experiment and you are using it throughout. The resistance of that bell will remain the same because you didn't change the bell. So whether the cell is now connected in parallel, it still does not change that the resistance of that bell is 13 ohms. We need that resistance to be able to do the II calculation. In II, we are asked what amount of current will be delivered to the bell if the cells are now arranged in parallel. So let us see parallel connection of the cells. If the cells are arranged in parallel, this is what the circuit will look like. But you know that we have already calculated the resistance of the bell, which gave us 13 ohms. Which gave us 13 ohms, right? So I hope you are following this, right? Which gave us 13 ohms. The resistance of the bell is 13 ohms. Parallel connection of the cell, this is what it's going to look like. And under parallel connection, you need to know the value of the internal resistance. Because when the resistors are connected, that is the battery, when the batteries are connected in parallel, the effective resistance of the cell will no longer be 1 + 1 we did under series connection. Remember, for parallel connection, what happens? You don't add resistance values straight on like that. Okay, R1 plus R2, you don't do that. For parallel connection, it's going to be 1 over R1 plus 1 over R2. So we need to get the effective, the resistance of the cell under parallel connection. Then coming to the electromotive force of the cell under parallel connection. When cells are connected in parallel, remember that they have the same voltage. So the electromotive force in parallel connection will be the same. Electromotive force in parallel connection will be what? The same. Which means that under parallel connection, E1 will be equal to E2 and it will simply be E, the electromotive force, and the value will be 1.5 volts. You are not going to do 1.5 plus 1.5 again. You won't, because this is non-parallel connection. For parallel connections, you know, if you have parallel cells, the voltages are the same. So here, our electromotive force E will simply be one of those guys, which is 1.5. But the internal resistance will no longer be 2, as we did 1 + 1 in I calculation. Rather, in this case, we're going to use 1 over R1 plus 1 over R2. But there's a faster way you can get this. You can simply do, to get the resistance of the cell under parallel connection, it will simply be 1 of the resistance value, which is 1 ohm, divided by 2. Funny, right? And the reason is simple. See, the internal resistance, they say they are the same. Each of them is 1 ohms. And you have only 2 cells. So you'll be getting only 2 internal resistance. And when you have the same value of resistor, I give you a resistor and their resistances are the same. Two of them, they have equal value. If I tell you to get the total resistance of those guys, what you're going to do, pick one of the resistance and divide it by 2. In fact, in your manual, you have that analysis there for parallel connection in the case where the two resistance values are equal. And again, in my video lessons, phase 102, I remember a workbook solution for those in Unizik. I had explained something like that before also. So what am I saying in essence? For the II part of the question, we need to get the value of total internal resistance of the cell. To do that, you must respect that the cell is in parallel connection. So you use parallel formula for calculating resistance, which is 1 over R1 plus 1 over R2. But since we have only 2 resistors and their values, the value of the resistances are the same, each of them is 1 ohms, simply pick one of them and divide by 2. So the resistance of the cell in parallel connection will be 1 over 2, which is 0.5 ohms. If you do 1 over 1 plus 1 over 1, right? Is that so? If you work that out, do the LCM, you are still going to get 0.5 as the total internal resistance. Then the electromotive force will simply be 1.5. Now, once you have achieved this, to get the current under this situation, the current that the bell will take, you now use your formula I equal to E over small r plus capital R as we used before. Now, let's proceed to the calculation so you see what I am talking about. I've given the analysis. Let us now take a look at the calculation. Look at it. Since the cells are arranged in parallel, the effective internal resistance is, so you can see, small letter r equal to R1 divided by 2. I now gave a note there so that you will be aware of what I am doing there. Remember, you still have exam to take on this course. So please, your interest should not be, let me go and do the practical. I am appealing to you guys. I could spend just 10 minutes. 10 minutes is too much for this calculation now. I can just use 3 minutes and solve this question, maybe on the board. But I decided to take my time to explain this. You still have practical exam to take on this. You still have phase 102, the theory part to take on this course. So you need to understand all of these. They are very important. All right, note, if R1 is equal to R2, then R is equal to R1 over 2. I've explained that. And so you do 1 over 2, you get the total internal resistance to be 0.5 ohms. On your own, you can use 1 over R1 plus 1 over R2 to solve it. You still get the same thing. I now went further to say, but E is equal to E1 equal to E2. Yes, the electromotive force will be the same because the cells are now in parallel. Voltages are the same in parallel circuit. So E will be 1.5 volts. With these parameters, use the formula I equal to electromotive force all over internal resistance plus external resistance, where that capital letter R is the external resistance, the resistance of the bell. With that, substitute your values. The current I will now be equal to the value of the electromotive force E, which is 1.5, all over, open bracket, internal resistance, small letter R is 0.5, plus external resistance, which is the resistance of the bell, capital letter R, is 13. If you solve out that, you are going to get 1.5 divided by 13.5, which is equal to 0.1 ampere. So do you see that the current that will be delivered in this case will be 0.1 ampere? That's the current that will be taken by the bell. And I hope you followed up with this calculation and you understood this clearly, so that whether it is for your practical work, it's going to be a boom. Trash it. If you see this in the exam, it's a walkover. Whether in the practical exam, if you see it in your phase 102, the theory part of the course, of course, it is CBT for you guys in Unizik. For others in other schools, it could be theory for you, but that one is not the practical work anymore. It's the theory work. You see something like this, you should be able to analyze it quickly without wasting time. All right, guys, so this is the much you can go. That's the solution to the question. And you can, of course, go through it, copy them, read through, get prepared for your practical analysis through this week, like I said. Okay, so this calculation we did where I went further to obtain E1, look at this one. Yeah, I went further to obtain E for 3 volts in terms of series connection, and then used it to calculate the external resistance of the bell. You need it, and when you are to do this, you can do it now, as in at this point. Get the resistance of the bell, because you know that you're going to use the resistance of the bell in the II calculation. Or you can take this second part of this calculation that started with also E equal to E1 plus blah, 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 you know. You can take it to the case of, you can take this calculation part to the II part so as to show how you obtained your external resistance of the bell to be 13 ohms. Then use it now to calculate that current exactly the way we did it. So I'm just saying, wherever I want to place this also calculation, the choice is yours. Okay? But this is what you're meant to do in this work. Remember the question we've solved. Look at it, question number 4 and question number 3, which I tagged question number 1 and 2. Question number 1 corresponds to question number 3. And then question number 2 corresponds to question number 4. All right, guys. Do have a wonderful day. Later today, we'll be taking Math 102 rather, in our physical tutorial on campus in Unizik for Unizik students. If you wish to join physical tutorial, then make sure you locate GMAT 41, okay? NK, hi. You're welcome to connecting to this class. Welcome. So you can join our physical tutorial by 4 p.m. today if you are a Unizik student. Today we'll be taking on the last topic on Math 102. No time. I don't wait for anybody. It's been months since school resumed, you know. So for you guys in Unizik. So today we'll be introducing conic sections. But in our online class, I've actually introduced conic sections with circle. All right. So you can join our class and you get coached so as to be able to blast your A's in these courses. As a final advice, please, before I end this class, please, I observe how this practical work is taking most of you students' time. I'm addressing this to those in Unizik for now, because I'm aware that the credit unit, the credit load of this course, the credit unit is 1 credit. Yes, this course is a pure A course. It's very simple, Phys 108. But hey, I've always been saying this, and I want to sound it as an advice and a warning. It's good you are connecting to this class, that's wonderful, but please, for your own personal information and good, remember that courses you give much attention to matters in university because of credit load. If you blast A in this course, the total quality point you have is 5. If you blast A in it, it's a 1 credit load course, so it's going to be just 5 points. 5 points. Permit me, I'm saying just, yes. Why I'm saying just is, if you give too much attention to this course just for the A, and it happens that this course made you not to give good attention to other courses that are like 3 credits, 2 credit units. That is to say, you allow this practical course of 1 credit or any other 1 credit unit course to affect you in getting excellent results in 2 and 3 credit load course. That result is not good. That result is not good. I'm going to give you an example. Imagine that you've been running up and down every week. Your practical stuff is something you learn once. For my students, I'd put them through all of these things. I'm going to drop a pre-recorded video where they were practicing this, in a physical tutorial and other things. And I had a work on electricity even before your set got admission. E2 of your manual, those in Unizik. And that particular practical, although the connection was in practical in parallel, and you were measuring voltage there. But it's still the same principle that applies to what you're doing in experiment E6. The knowledge that could have guided you here that you shouldn't even have been worried about your physics practical. Your light stuff had done works on them. All of you are aware of it. So since you could have covered this, so that you can now give enough time to other courses of higher credit. Imagine somebody getting A in this course now, and then in your math 102 or physics 102, you are getting C. That is a very bad result. Yes, it's a bad result as long as university is concerned with credit load. So I want you, dear friends, please to ask yourself this question. Ask yourself this question. Most of you have disconnected now, so I'm advising you on this. That's a mistake that some of you will make, such that at the end of everything, getting first class might now be difficult. Please, there is a secret to blasting first class or even second class upper in university. So ask yourself this question. Have you covered your 2 and 3 credit load courses well? At least, let us say up to 60 to 70% as at this point. Because your exam is very close now. Those in Unizik. I think you are taking your exam first week of August. So if you have not covered your 3 credit load courses, I used to know, I think Math 102, Physics 102 course. This course you guys call is it called COS 102 or BCSC, right? Then there's a bio also, I guess there's one is a 2 or 3 credit load course. What about your Chem 102? All these your 2-3 credit load courses, please start giving serious attention to them. As at this point, if your exam is coming up from I guess first week of August, then you should have covered nothing less than 60 to 70% of your higher credit load courses. Like I said, somebody that spends time, you spend much of your time on this practical, which is 1 plus 1. All this is 108. It's 1 plus 1. Because of course you have good assistance to this stuff. This channel covers everything. You make an A here and then you are getting C in your 2-3 credit load course. It's a very, very bad, it's poor result. So give much attention to your 3 credit load course, the most. Next to 2 credit load course, and then to 1 credit. That is the order you have to give attention to your courses. See, if you blast an A in 3 credit load course, the quality point total you get is 15 points. 15. Just imagine. Your GP will start booming and floating. If you smash A in 3 credit load course and maybe for any reason you get a C in 1 credit load course, the 3 credit load course will help to jack up. Are you following, right? To raise that 1 credit load. But if you smash A in 1 credit load course, just 5 points. I am not saying you should go and get C or whatever. If that is the reason for saying this, then I wouldn't be doing all these practical works for you guys, even doing life works for you. I want you to get A because it is very simple, easy to make A in this your physics practical. But I'm now telling you, don't allow it to affect your higher credit load course. Please start giving serious attention to your 3 credit load course. Okay? And then next, your 2 credit. So when it comes to taking video lectures on all these courses, please start taking lectures on Math 102, Phys 102, Chem 102, your bio courses. Are you following? You know all those courses that are 3 and 2 credit load courses. Please. Just a loving advice from someone that cares. Thank you for connecting. Have a wonderful day. Right? I'll meet you guys later this evening. We are going to look at the work on GMAT 41 Fastest Finger Academic Challenge. Yesterday, we had that challenge. All right. I'm going to declare the winner. Make sure you join the challenge. I think it's going to come up by 8:30 p.m. 8:30 p.m., right? Sorry, by 9 o'clock p.m. 9 o'clock p.m. We considered Chem 102 yesterday. So today, we are going to trash Physics 102 and Math 102 in that Fastest Finger Academic Challenge, just to help you expand the network of your brain. There is a prize attached to it. but that price should not be your priority, okay? All right, bye. I think we are done for today. See you later in the evening.